Welcome back to another introduction to insect taxonomy and identification. Today I thought I'd jump around a little bit because of some interesting stuff that was in the news that inspired me to talk about a different group. So we've talked about the Antenatha, the wingless primitive insects, the Paleoptera, which are the insects like the mayflies and the dragonflies, which can't fold their wings behind them. And then we've begun on the Neoptera. We've begun talking about the stoneflies, termites, and roaches. And these are the insects that can fold their wings. Below this line here are the insects that can fold their wings behind them. These are the Neoptera. But so far we've been talking about just the hemimetabolous insects, which are insects that only have a partial metamorphosis. The adults and the juveniles look very similar to each other. Basically, the juveniles just grow wings, and otherwise they look very, very similar, if not identical. But I want to jump all the way down here today. I wanted to talk about a group of Lepidoptera called the Megalopygidae. Let's see. Megalopygidae, which are the flannel moths. And there was an article that came out from the New York Post saying that there were megalopygids that were causing quite a bit of distress in people in Florida. They had just been hit by a hurricane, so there are a lot of downed trees. And megalopygids tend to reproduce in said trees, typically oak trees and elm trees. And so while they were cleaning up the megalopygids, a lot of people were getting stung because this group produces stinging caterpillars. So these are holometabolous insects. Everything below this line here, these are holometabolous, which means that they go through a complete metamorphosis. Specifically, it goes from egg to caterpillar to pupa to adult. So a complete metamorphosis. The juvenile insects and the adult insects don't look anything alike. They frequently have completely different environments in which they live. They frequently have completely different food sources. And the evolutionary benefit of this is that you basically open up twice as many resources to the species because the different stages of the life cycle use different resources. Whereas in the hemimetabolous insects, because the adults and the larvae, or the adults and the juveniles, the nymphs, tend to be very, very similar. They tend to occupy the same sorts of niches in the environment. They have a lot of the same food sources. They occupy a lot of the same space. And so you end up with competition between the adults and the juveniles, and that doesn't happen with the holometabolous insects. So I wanted to talk about this group of Lepidoptera today. Like I said, these are the megalopygids. So the Lepidoptera, we haven't discussed this group yet. And it is a very, very large group. The Lepidoptera are the scale wings, which is what that name means. And these are the butterflies and moths. Butterfly and moth. It's a very, very large group, as you can see from this little diagram I did here. The superfamily that we wanted to talk about when we're talking about the megalopygids are the Zygonoidea. And there are 45 other superfamilies in this group. So 46 total, and that could be changing. It's always up for debate. And within the Zygonoidea, there are 13 families. So just an absolute enormous number of moths represented here. And the megalopygids are the moth, is the moth family that we want to talk about today. There are 4 genera in the continental United States. As far as I could tell, there are either 11 or 12 species, depending on kind of where on the Mexican border you're looking. Maybe they're in Arizona. One of these species is in Arizona and New Mexico. Maybe it's not. So I would say 12, because it probably flies across the border occasionally. So 12 species occur in North America. In this superfamily group here, the Zygonoidea, generally, these are woolly moths. The adults have they're very, very fuzzy. They're kind of stout. And they have bipectinate antennae. So, pectinate. So, this literally is like 2 fish. Basically, the antenna looks like it is kind of super fuzzy, and I have pictures I'll show you, but it basically looks like a fish's rib cage. It's super fuzzy, super frilly, and kind of looks like little fish bones all over the place. The megalopigids within this group have all of these characteristics, but they also their caterpillars are very unique. They are stinging caterpillars. They are extremely hairy. They have 7 sets of prolegs, which is unique amongst caterpillars. Most caterpillars only have 5 sets, and they are covered, like I said, in secondary setae. So let's take a look at a flannel moth. So this is an adult flannel moth. They're pretty adorable, kind of like little flying teddy bears. They are extremely furry for the most part. When Lepidoptera look furry or covered in setae, they're actually covered in scales. And the difference is that setae tend to be long and pointed, and scales tend to be flat and broad-ended. So if you were to actually look at these setae under a microscope, you would see that they're actually modified pretty significantly. Although a lot of moths will have setae still, setae still on this portion of the body, and then when you look at the wings, they tend to have more scales. And the setae will extend to the other parts of their body as well. So the adult megalopigids tend to be very, very setose, so both scales and setae all over the body. This, in particular, this is Megalopygidae opercularis. This is the southern flannel moth. It is extremely common, and when I was talking about the stinging caterpillars, this is the one that I was talking about. It's very common in the eastern half of the United States, especially in the south. They tend to feed a lot on roses and oak trees and elm trees, things like that. Generally speaking, the megalopigids will be found more commonly on trees and shrubs than like in grass. Or low-growing soft plants. But along with this, there are 11 other species, so 12 in total. And then if you go into Central and South America, there's even more species. This is, as far as I know, this is entirely a New World family. Again, this is another photo of that Megalopygidae. Frequently, they are kind of this yellow-brown color. Sometimes you'll find them with stripes and spots and things, but there are a few other ones that are quite brilliantly colored. So this is Trosia. This is another genus that you will find, but they do have occasionally with much more bright, colorful sorts of wing patterns. There's a few that are all black with big red spots, things like that. But generally speaking, they're closer to this southern flannel moth color, where it's kind of like a rust red, a yellow, and a few bits of white and black scattered around. Their caterpillars, however, are very distinctive. So this is what a puss caterpillar looks like. They're called puss caterpillars because they're supposed to be furry like cats. But the head is here, and then the body would be completely cloaked under this enormous mass of setae. And you would have your 3 thoracic legs there, and then you would have the prolegs here. So generally on moths or on caterpillars, the prolegs are on 3, 4, 5, and 6, segments 3, 4, 5, and 6 of the abdomen, and then segment 10. But these guys also have little kind of like reduced prolegs on 2 and 7. So the caterpillars themselves are stinging. They're covered in setae that can sting, and these are all secondary setae. So when I talk about secondary setae, this is something that is very important when we discuss caterpillars and how to identify them. So this is not a megalopygid caterpillar. This is a pyralid. When you're trying to do identification of a caterpillar, there's a few really important parts. The head is really important. The prolegs, these are the prolegs here, are really important. So this is abdominal segment 3, 4, 5, and 6. And then you have another one on segment 10. And the arrangement of the crochets of the prolegs are really important. Basically, these prolegs are covered in little hooks, and those hooks are how they cling to surfaces, and the arrangement of those hooks is really important. But also of major importance are the setae, and the position and count of the setae. So you see all of these long hairs. These are the setae, and these particular setae are called the primary setae. And these primary setae exist in this arrangement on basically all caterpillars. And sometimes they're moved farther dorsally or farther ventrally. You can see down here, there's some coming off this ventral surface, and there's a few on the lateral surface. But this arrangement of, if you just look at segment 3 here, the arrangement of the setae is diagnostic for caterpillars, either to family, genus, or sometimes species. If there are other setae, they're called secondary setae. So all of these setae are named. These are the primary setae. All of them have a designation. But on something like the puss caterpillar, they still have those primary setae embedded somewhere in here along the body. They still have them if you were to strip away all of these secondary setae. But all of these are secondary. I love how he spelled that. That's so stupid. Secondary. So all this fur that you're seeing, these are all secondary setae, and they are without names. So when you key out a caterpillar, the secondary setae aren't particularly useful, other than whether or not they're present. But additionally, underneath all these secondary setae, they have patches of spines or modified setae called verrucae, and these are extremely sharp, venomous spines, and they occur on patches scattered pretty equally all over the body. And so if you touch the secondary setae, you won't get stung. But if you grab it firm, you will hit these verrucae setae, and you will get terrible, terrible poison injected into you. Particularly with this southern flannel moth, which is the caterpillar that we're looking at here. It injects an enormous amount of toxins. The toxins are described as equivalent to broken bones or blunt force trauma to an area, white hot pain that can last for hours or days. Some people have extreme reactions to that and will send them into shock and they need to be hospitalized. You definitely don't want to go grabbing one of these off of a tree if you see it. You can if you want to collect it, you can kind of coax it. I've collected a few of these and then raise them into the adults, and it's not that terrible. But yeah, so when you're talking about these sorts of caterpillars, if you get a setal map, which is basically a diagram drawing of the arrangement of the setae for a particular species or anything like that, you would have to peel away all of these furry secondary setae in order to find the primary setae. So there's only a handful of these megalopygid species within the continental United States, only about a dozen. I will link all of the known species in the description box. You can look this all up on Butterflies and Moths of North America website, as well as on something like Bug Guide. And if you want to take a look at all of these, you can. As a reminder, when I was talking about those bipectinate antennae, this is what I'm talking about. You can kind of see that they're flayed out, kind of like fish bones. Here again, this would be, I believe this is the male's antenna, although sometimes with the megalopygids, the females will also have this antennal arrangement. But they're a fairly easy group to recognize, especially if you are talking about moths as opposed to butterflies. These are very distinctive moths. They're not like the little brown and gray moths that are really difficult to identify. So keep an eye out for these, especially in the fall. You'll frequently find the caterpillars roaming around your trees. And I'll talk to you guys later. Thanks.